Okay, testing for symmetry. I have the book here next to the whiteboard here, or blackboard, let's say. Test for symmetry. It states that if you're looking, or if it's symmetric with respect to the x-axis, okay. Here, if and only if for every point x and y on the graph, the point x and negative y is also on the graph. So in other words, we're replacing y with negative y. So the opposite. So if you're looking for symmetry within the with respect to the x-axis, I am going to replace my y with a negative y. Same with, here's the y-axis, x with x, negative x, and then origin would be both x, negative x, and negative y. And this is how I like to kind of organize things. I'm going to do my test on x-axis, y-axis, and origin to see where it's symmetrical. My function is right there. Okay, so let's start solving this one. Okay, so for x-axis, my y will now equal negative y. This, for my y-axis, x is now going to equal negative x. And this one is going to be negative x that we're going to use, and then negative y. Okay, let's plug those into this, our formula here. So we have x minus a negative y. Well, that's a weird y. Squared equals 1. Okay, I'm going to do the same thing here, and I'm going to change the color because it's mixing together. So now I'm replacing my x's with negative x's. So I'm going to write a negative x minus y squared equals 1. And on this last one, x and y are going to get a negative. Okay, so now we just simplify. Well, I can take the square here in this first one here, and take that square of negative y. Now I have negative y times negative y. Those are two negatives which make it a positive. Make it a positive, right? And I still have that minus there. I still have this minus goes here, right? But then this minus cancels out when I multiply those two together. And I'm left with just y squared. Okay, equals 1. Then here, this negative x that we just plugged in here, well, I can't really do anything. There's no square there. There's no, there's nothing there to simplify. So this is kind of like my final simplified equation. Okay, so now for this one, this square is including this negative here. So negative x, I can't do anything there with that negative x. I still have that minus there, so I'm going to write it here, minus. And then this minus, gone, turned into a positive because of the square. Now I'm squaring that y, so that's a square and a 1. Okay, now we ask ourselves, which of the, once the equation is simplified, which one is identical to the original? Well, the original is up here, okay? And it looks like our winner is the x-axis, which is true. Your graph looks something like this one. Instead of having a sharp end, it's more like this. And going that way, right? So that's how we do that.